Try to do this very, let me see, okay. So I'm gonna give you a really brief overview of some of the work that we have been doing over the last, 20 years. We have a research center. It's called the National Center for Airborne Laser Mapping. It has been funded for 20 years by the National Science Foundation. And we started, and I did not start that. I mean, that was other people, but it got started to provide research quality airborne LIDAR data to people like you, geologists, geomorphologists, and people in the earth sciences. And we still do that. I mean, we've been to all the way from Antarctica to Alaska, all across the US, Puerto Rico, Hawaii, all the cool places where other people go on vacation, we go and work, which it's cool to take your wife with, sometimes. But at some point, there was a pair of collaborators. One was an archaeologist, and the other one was a biologist. And they both were working in Belize, and they heard, for many years, people in Europe have been using LIDAR to find Roman forts under vegetation in different parts of Europe. So they thought, it would be cool if we actually applied that technology in Mesoamerica. That was 2006, and for all of those students that are there, keep in mind that when you get a rejection, that does not mean that you're dumb. It means that you have to keep trying. So these people were applied for funding to do this project, and were denied multiple times until the third or fourth time NASA said, okay, let's try LIDAR in Belize, and the rest is history. And I'm going to cover that part of the rest is history. What I have for the rest of the evening, I can go deep into one particular project, but I think I'll do what the bad TV shows do, and instead of doing one full thing, they do 10 small things of something very little. But I think it will be good to give you a sense of what we have been doing, and give you a sense of how technology can change the understanding of what we humans have done on Earth. I also have to say, I'm here presenting, but I actually stand over the shoulders of an entire village. And this village, it's actually people like you, professors, researchers, that actually are the ones that write the grants to get us to go to different places in Mesoamerica to actually do the LIDAR collection. These are actually a group of earth scientists, not archaeologists, but they were the ones that actually had the first workshop that eventually turned into the research center that we operate today. And of course, when we go out, I might be one person in the airplane, but there's one or two pilots, there's other people on the ground setting GPS-based stations, there's people driving us around and stuff like that. So whatever I'm talking to today, I'm actually talking for hundreds of people, right? So it's not only me. This is a dated map, and it shows some of all the projects that we have done in Mesoamerica. Let's understand Mesoamerica as the area where corn tortillas were invented many centuries ago, right? So if you had a corn taco recently, it's Mesoamerica. So, but basically includes Mexico, the southern part of Mexico, Guatemala, Belize, El Salvador, and Honduras. By the way, I was born in Honduras, and there's a part of the story that I want to tell later. And this is a dated project, a dated map, because it's based on the things that have been published. A lot of the really cool stuff has not been published, and I cannot talk about it. But if you buy me a beer or two, maybe I'll spill some of the beans, so to speak. To date, we have a research center has conducted over 60 different projects in Mesoamerica, and we have mapped over 20,000 square kilometers with high density airborne LIDAR data. This means more than 15 pulses per square meter. And I know for those of you that operate drones, that sounds like very little, but for those of us that actually operate real airplanes, that's a lot. And costs a lot of money. So some few introductory words. Discovery, it's a dirty word. especially like when you talk with in terms of archaeology and anthropology. And the reason is like we, in our ignorance, might think like because something is not on a record, it does. I mean, people don't know it. We don't know it. Modern science does not know it. But there's indigenous people out there that actually know where things are, right? That it has not been brought to the books. That's a different story. So we have to be very careful when we use the word discovery. I don't use it. I'll probably use it a couple of times, but keep in mind that what we know, it's a bad thing. Really bad because the media likes to use that word, right? Like that word, like okay, a professor from the University of Houston discovered that, and first of all, it was not a professor; it was a group of people. Second of all, it was not a real discovery. The other thing that is a little bit sad is the fact that most of the time you're actually applying these technologies around areas that are fairly well known. Meaning it's an area where a professor has been working and can write the grants to get the money to do LIDAR, right? But very, very, very little money goes into actually doing real exploration that is actually going into the areas that are really uncharted. And that's something that I think the way that the grant system works in academia in the U.S., favor things that are not really the high risk, high reward. They kind of reward mediocrity, right? Like if you have done some things that are kind of cool, then you can continue doing that kind of things. But it's really hard to actually advance the knowledge into things that are completely unknown. So a very brief overview of some of the things. So this is my conclusion slides, and I give you the conclusions right away because that way, when I run out of time, at least you know what are the conclusions, right? So what we have learned with LIDAR is that we are actually mapping. One of the cool things with LIDAR is that we map not only archaeological sites, but we map the archaeological site in context with the landscape, and the landscape includes both the topography and the vegetation and the hydrology and all the stuff around. That kind of mapping was very hard to do 20 years ago using traditional survey techniques. We are very lucky that we are able to find sites that are uncharted, again, unknown to modern science. But also the sites that have been mapped for 10, 20 years using traditional field survey, they tend to be much bigger. Well, whenever we do a LIDAR survey, it's always bigger, much more complex, much more elaborate than originally they thought it was going to be. We have found that humans, we are really good at actually going into places that we think we should not go. Well, anyway, we live in Houston, we know that we should not be here, but here we are, right? So the same thing was true with the Maya, right? They went into places why were they there? And there's an abundant evidence of large-scale human modification of the natural terrain for water management, agriculture, defensive features, and other things that it's really, I'll show you some examples of, you definitely have to think, how did they build that? I don't know how they built it, but I know that it was not aliens. So don't ask me about that. So the Maya world, again, it's this area that is represented in avocado green, and it's green because they invented the avocado, right? They developed the avocado, right? And the guacamole, right? But it's the southern part of Mexico, big parts of Guatemala, Belize, Honduras, and El Salvador. It's important. I'm going to show you a map, but you guys are geologists, you know that it's not only the location that is important, but also how it has changed over time, right? So I'm going to show you some snapshots of how things look today, based on how they looked when they were abandoned thousands of years ago, right? But the real key is not only where it's located and what's located, but the crucial thing is what time period we're talking about. Was this 2,000 years ago, 3,000 years ago, or even further, right? That's a big question, and that's the real question that archaeology tries to answer, and that's something that, despite how good LIDAR is, we cannot really tell how old is something just because of how it looks. Okay, so I'll show a bunch of images, and I realized that whenever we show these images, we assume that the people in the audience know what we're seeing, right? So in order to make it clear, let me say that and I'm sure this is not new to you guys, but when we collect mapping LIDAR, what we're collecting is basically just three-dimensional coordinates, an X, a Y, and a Z, latitude, longitude, and elevation, right? And that's LIDAR. That's the LIDAR data. It's just like a collection of points, numbers, that we can represent as a point cloud, right? You have heard this term, right? And obviously, you see that it's a cloud made of individual points. Each one of those points in that profile again, has its coordinate, it has some other attributes, right? The real key thing, and like where the real cool thing happens is like when you are able to assign a label to each point, right? Like this point was coming from the vegetation, or this point is coming from the ground, or this point is coming from, in this case, a pyramid in southern Mexico. So that's LIDAR. That's the first kind of data that we have, but through 2D interpolation, we can turn this unorganized list of points into a table. A table that is like, for a given X and Y coordinate, it will have a single elevation value. And then we turn these tables into a bunch of images, and those are the images that I'm gonna show. So keep in mind that 99% of the images that I'm gonna show are just elevation, different ways in which we represent elevation, right? Very similar to some of the figures that we're gonna see next. So I'm gonna go through my list of the top 10 discoveries, although again, discovery is a bad word, but nevertheless. And this is no particular order, like in terms of importance or chronological importance, it's just some way that I have find that it's a good way to tell the story. So I'm gonna start with the most recent discovery that was made. And this, that's on the left side, that's a printout from the story from the New York Times. Like the title says it all, like on the map there was nothing, right? But on the ground, once the archaeologists were able to go and verify the LIDAR data, it's a complete new, let's call it settlement. Some people, and in the media especially, they use the word city. But the word city has, if we talk of a city right now, we tend to think in the magnitude and the scale of a city today. Back in the day, the cities, even when they were cities functionally, meaning that there was like a commerce, there was like industry, there was arts, there was religion. Even when functionally it was a city, the scale is much smaller. But this is a settlement that is significant in size. And what's really cool about this is that this was a project that was done in one of those areas that was completely uncharted. So somebody decided to put the money to actually go and do real exploration. And what came out, like a true Maya city, if you wish. So it's cool that even to this day, there's things that we can discover if we want to. Again, discovering like our modern context of discovery, right? So what I'm showing here is just like, let's start with what the New York Times image shows. It's actually a hill-shaped map of the terrain elevation. And this, I call it the kangaroo city. I don't know if you can see, it has the shape of a kangaroo. So I don't know why the Maya settled on the kangaroo mesa, but this is very similar to Houston. You have some highlands, let's call it the heights, and around the heights there's a bunch of lowlands, right? A bunch of wet areas, right? So in the terrain that it's a little bit elevated, they created all this complex network of pyramids, temples, and residential infrastructure, roadways. Over here, you can see the trace of a road. So again, you can see the LIDAR data presented as a map, like a traditional map, a top view map of elevation that's hill shaded. But you can also represent it like in a perspective view, and you can color the elevation. You can color the things based on the elevation, from lower elevation in the blues to higher elevations in the red. And the most important thing that they did not show about that image is that all of that, it's covered under a lot of vegetation. So if you were to take a satellite image, all that you will see is like just a big broccoli. And that's how LIDAR has been transformative to archaeology. It enables archaeologists to actually do explorations in areas that are highly vegetated, right? What kind of things we see? Well, we're gonna show you a little bit more here. So from the most recent one, let's go to the first one. And again, I was mentioning that there was a pair of researchers. One was an archaeologist, or is an archaeologist. Oh, and by the way, he's at UH. Well, a couple. And there was a biologist that he's still at University of Central Florida. That they have been working this area in western Belize called the Baca Plateau. And in the Baca Plateau, there's a Maya site called Caracol. So they have been working for 20 years doing traditional field mapping. And they had mapped about 20 square kilometers, a square kilometer per year, right? And all of a sudden they say, okay, let's try this. And they got the money, and like, I was not there then, I was a student. But the team went there, and in a matter of a week, they mapped 200 square kilometers. That's a 200 square kilometer area, and it's kind of, I mean, that's the elevation, the digital elevation model of the terrain. This is another way of representing the LIDAR data. But what I want to show on the left side, it's actually how LIDAR is made. And this is the part that it's like the horrible part. So basically, we have to fly an airplane and fly a bunch of parallel lines. In this case, they were not only parallel, but also perpendicular. And it's like mowing the lawn, right? I mean, like you fly a line, you turn around, you fly another parallel line, and you keep doing this until like you map the entire area. So when people ask me, can I go on the plane? I say, like, you know what? The first 5 minutes are really cool, but the next 4 hours are really boring. So, like, you know, if you want to do that, come with us. But you know, there's no bathroom there, there's no snacks, and no. You can bring a drink, but like, you know, it's bad. And so a lot of times it's spent like, you know, just turning around and stuff like that. For every hour that we spend mapping a line, we probably spend between 4 and 10 hours actually processing data in the lab and actually producing these images. So this was one of the first projects in Caracol. And so here are some images. This is a shaded relief map of the first surface, meaning the first surface of the laser map. So, you know, this is the broccoli that I mentioned, right? I mean, like, I can also make it in color, but like, you know, this is the way that traditionally they were made. And you can see a modern road, and then you can see something that looks like a pyramid, but the real cool things come once you remove the canopy, right? And then this is a topographic map, hill shape of the bare earth model, or the bare earth, or the terrain elevation, and also includes some of the architecture. For sure, you can see, I mean, I have there with a green arrow, like a big pyramid, and like, you know, that's obvious, that's a pyramid. And that's what they're after. But what was not, like, you know, so, they were not so certain of how other things will show up. It's like this network of roads. I mean, they're called causeways. Let's not call it roads because roads, then you'll think like, you know, they had like a car or a cart or something that they you know, drove around. But you see, I have a couple of them marked with a yellow arrow, and you can see that, like, you know, it has the same trace as the you know, they look very similar to a modern road. So, I mean, for all intended purposes, let's call it a road. But some of the things that were very interesting for this image were the terracing. The terracing all over the LIDAR data, right? So they had a lot of terracing for agriculture, so they had a lot of tortillas and a lot of avocados. The other thing that, like, you know, they were important for them, another resource, is water. So with the orange arrow, I'm actually marking a little depression that it's actually a water reservoir. People ask me, is this like a natural thing, or is it like a completely man-made? And, like, you know, it's a combination of both. They took advantage of a low elevation area, and then they built around to create like a, you know, more holding capacity. This is another way of actually representing the same data, right? Like in a perspective view, we have color also the elevations with a ramp, color ramp, and you can see, again, the same features, right? Like you can definitely see the pyramid. I have a photo of the pyramid as you can see it from the air, and all the trees that are around. But the other thing that you see, again, is the pathways and the terracing. So that's once this was seen, they said like, okay, this is gonna change, because even when you can spend 20 years mapping the big structures and stuff, there was no way that they will get all the details of the terracing, and that's where a lot of the really cool things happen. Not on the big thing. Finding a big pyramid, it's cool and stuff, but it's not as significant as finding something small that tells a little bit more about the culture. 37, okay, I have about 9 minutes. So I'll try to go quick. So remember those causeways, those roads that I mentioned. We have actually mapped the longest known Maya causeway, and it basically goes from, well, for those of you guys that do scuba diving, you probably recognize Cozumel Island, right? And of course Cancun, and Tulum, it's a little bit to the south. But it basically goes from the coast on the coast across from Cozumel all the way to Chichen Itza. It's more than 100 kilometers long. Here I have just a small section, and you can see the kind of something that looks like a modern road. This is a close-up view, and this is a 40-meter wide causeway. So the way that I compare this for you guys that are from Houston, this is basically 288 in length from Houston all the way to the coast. And it's in the parts of 288 that it's four lanes wide. I mean, so that's what they were doing back then, right? Big question is, why were they investing these kind of resources, right? I mean, did they have the car? They did not have the car. All the evidence that we have suggests that they were just doing this for actually moving people back and forth. Another cool thing compared to Houston, have you seen that every year they resurface the roads, right? And they last nothing, right? 6 months later, they are all holy, right? You have a road here that lasted 2,000 years in similar Houston weather. Okay, so another thing, and this was cool because in the same year, in 2016, we did 3 projects in 3 different countries, and we were not aiming for this, and the archaeologists were not aiming for this, but we found for the first time evidence of wetland agriculture. So they had a wetland, and they were able to do one of two things. Number one, they were able to cut a canal in order to drain the water, in order to have land that was a little bit wet but not too wet, or they were able to get soil and pile it up and do little islands or raised fields in order to do agriculture that way. So this was the first one that we saw in Mexico. And what I have there is just you can see a bunch of linear features that, I mean, if you don't know what you're looking at, I mean, you might not know, but that's actually evidence of when they were using canals to kind of drain the fields or irrigate the fields. This is in Belize, and this is really cool because here in these images you actually see a little bit more of the complexity and the structure that was done, right? On the image C actually shows some of the canal areas, and image B shows some of those that were kind of raised fields. We also were cool enough that these are B, C, and D are topographic representations of elevation, but image panel E, it's actually not based on elevation, it's based on intensity, on the measure of the reflectance of the signal. And we were able to see the wetland fields in the intensity because the areas where you have a canal usually holds more water, and it has a different signature than the areas that are drier. So we can even see, on the surface that it's flat, we can actually see where were canals because they still hold water. These are more examples in The panel to the right, it's actually close to the Maya site of of Tikal. And what we have here is just like extensive areas of agriculture. Why is this important? Because we can, I mean, they were humans like us, they needed to eat, right? So with these kind of things, we can actually quantify how much corn was available to sustain a given population, right? And there's a lot of very interesting things that can be figured out from that. I want to show some other examples of water management features. This is in the PUC in northern Yucatan Peninsula in Campeche. And you see a bunch of things that look like little craters. So those craters are actually pits or holes in the earth surface that actually are like the entrance to underground cisterns. So every pit that you see there, it's a hole similar to the one that the archaeologist is going to go into with the ladder. And once they're inside, you have like, big cisterns like this. And this is an area in Yucatan where there's like no surface water, so they had to collect their water, right? So they were able to maintain societies just by collecting rainwater. The image there to the bottom and the left is just like a LIDAR 3D map from inside a cistern. So the red thing that you see on top, it's like a little building and structure, and you see how big was the cistern in relationship to the thing on top. So I mean, this is the case in which you only see the tip of the iceberg, right? And the big iceberg, it's actually underneath. We cannot see underneath the air surface. You had to send someone with a LiDAR system inside to actually map that kind of a thing. These are some examples of actual reservoirs that were cut into the surface, right? And these things are probably 2 football fields side to side. So imagine the amount of work that went into that. But I mean, we need water, right? We need the mice and the water to survive. So there's a Maya city that everybody knows, or at least everybody that has seen the Star Trek, right? And this is the Maya city of Tikal, right? I mean, you can see the pyramids there when the Millennium Falcon was like flying over and came to land there, right? But I mean, do we really know the city, right? I mean, if you were to fly in the Millennium Falcon today over Tikal, this is what you'll see. A bunch of green with some white specks. But once you remove the vegetation, wow, you have, and this it's an actual Maya city, right? I mean, by scale, it's the core city, it's probably about 2 square kilometers. But it actually extends over an area that it's probably hundreds of square kilometers. And one of the things that we were looking at that in that particular project is that like the city of Tikal has a wall, and this is one of the cool things of this kind of a thing. Like the archaeologists were very certain. Okay, we have an 80 square kilometer LiDAR survey around Tikal. Most likely, we're going to find all the wall. But no, that's the edge of the survey, and the wall continues, and we did not get it. So we had to go back in 2019 to get another 200 square kilometers on top of that. And you know what? We did not get the entire wall either. Yeah. So because this wall in a particular segment is has a radius from the center of the city of 5 kilometers, you can imagine how big the area that was protected by the wall was, right? And this is one of the cities that, because of the wall, we can probably say it was this big once we find the entire thing. The Mayas were very, they like to fight with their brother, right? So part of the investment that went into land management was actually to build defensive features. So this is in a site called Honmul. And you can see that it reminds me of a medieval fort in Europe, right? Where the hill was actually fortified around with walls. A very interesting case also in the same survey in 2016 is the site of Tintal, that's to the west of Tikal. And what I have there with a mark with a yellow arrow, it's actually a canal. And this is an artist's rendering of that kind of same thing. But they had a canal, they built this canal that has about 0.5 kilometer in length. and it was a multi-purpose system. I mean, it was both to hold water, store water, but also like, as a defensive feature, right? You can, I mean, they had real crocodiles there, not like in the cartoons. I'm kind of running out of time, but I think I can, very, very little. And maybe I'll just go very quickly through these. So I guess like you guys probably have the same thing that archaeologists have. The coolest find always happens the last day of the camp, right? And like, so we have something similar in LIDAR, and actually the coolest things always happen at the edge of the survey. And like you want to see what's more. So this was something that we did in 2017. And basically the archaeologists had like, that orange rectangle. That's what they wanted to map, and they had to find the main site right there in the edge of the polygon. But, and this is the good thing of actually doing things manually and not having computers do it for you. But when we manually turn off and on the laser, when we're flying a line, we extend beyond the boundary. And what happens is in the boundary, at the edge in the northeast corner, there was something there. And well, that something that looked like, in itself was bigger than the main site there, turned out to be this massive platform. And this massive platform, it's like, just in case you don't see it, that's kind of brown area. And that's like, a good 1.5 kilometers long by 250 to 400 meters wide. And the cool thing is that the archaeologists had actually walked over this. But when you walk over this, what you see, it's like, a flat area. It looks like a ballroom. And this is the cool thing that LIDAR brings, is the ability to, elevate yourself and see it from a different perspective. So, so this is the largest and oldest Maya platform in the world. You know what? I have a few other slides, but like, they are not important, that important. Because at the end of the day, the key points is that, when we go and try to find things that we think we know, we realize that what we think we know is very limited, and we really don't know what we don't know. So that's why we have to keep exploring, especially the students. Thank you.